I am Dr. S. Satish Kumar, Institute of Aeronautical Engineering, Hyderabad. Now I am going to discuss about the topic of natural fiber composites for engineering applications. So, what is the definition of composite materials? A material system composed of two or more physically distinct phases whose combination produces aggregate properties that are different from those of its constituents. So generally, one material forms a continuous matrix while the other provides the reinforcement. For example, the concrete reinforced with steel, epoxy reinforced with graphite fibers. Similarly, plastic molding compounds containing fillers and rubber mixed with carbon black. So these are all the examples of composite materials. Okay, see that last one, that reinforcement plus matrix forms a composite material. Okay, next, what is the classifications of composite materials? So based on the matrix form, the composite materials can be classified into ceramic matrix, organic matrix, metal matrix, as well as this organic matrix classified into two. First one polymer matrix, second one carbon matrix. Similarly, the polymer matrix can be split up into two. First one thermoplastic and as well as thermoset matrix. Furthermore, the composite materials can be classified based on the reinforcement of metals. So metal and or non-metals. So what are that one? First one, fiber reinforced, particulate reinforced, structural reinforced. That fiber reinforced can be classified into two. First one, glass and carbon. Similarly, that structural reinforced also classified into two. First one, sandwich, the second one, laminated. Okay, so what are the main classifications of composite materials? That according to reinforcement, that composite can be classified into 7 types. First one, fibers. Second one, viscous. Third one, laminar. Fourth one, flakes. Fifth one, filled. Sixth one, particulates. And seventh one, microspheres. See, the fibers can be classified into 6 different types. First one, short fiber, long fiber, plies fiber, threads, and organic as well as inorganic. So according to the reinforcements, the different type of diagram as shown in this slide. See, why we need natural fiber composites? First, we have to discuss about the natural fiber. After that, we will move the natural fiber composite. See, first one, that environmental region. Second, renewable sources. Next, thermally recyclable, biodegradable, and carbon dioxide neutral. Okay. So what is that? Fourth one, that low energy consumption, which means low carbon dioxide and low carbon footprint. Next, cost. Potentially, that means compared with other composites, very, very low cost. Similarly, it is very useful for our health and safety. Okay, so similarly, it considered only less abrasive and safe to handle also. Next, according to the mechanical and tribological properties, it will give very good and perfect result and better result also. Okay, so next, the design aspects. If we are going to take design aspects, it will give natural image and aesthetic images of any area. Okay, similarly, it is very lightweight structures and high modulus values. In that thermal expansion area also very low coefficient of expansion. Okay, that DMA, that means dynamic mechanical analysis, also very good. That means it is considering in the good acoustic and vibration damping capacity. Okay, next one, increased recycling possibilities. That means better energy recovery also possible in this natural fibers. That last one, energy and less environmental impact due to material production. So it is not affect the overall environmental during the fabrication or production of composites. See, next one. This is worldwide production of natural fibers. Actually, in this diagram shows worldwide production into 10 to the power of ton value. So, for example, here I am considering that oil palm is yellow color. It indicates 7227. So, we have to consider into 10 to the power of 3 ton values. Okay, so according to the worldwide production, the natural fibers helping to the overall environmental production or worldwide production. Okay, what are the classification of natural fibers? So according to that natural fibers, it can be classified into plant fiber, animal fiber, and mineral fiber. The plant fiber categorized in 5 types. First one, seed fiber, leaf fiber, bast fiber, fruit fiber, and stack fiber. As well as that animal fiber can be categorized into two, animal hair and silk fiber. That last one, mineral fiber. Mineral fiber category is six. First one, amosite, rosidolite, tremolite, actinolite, anthophyllite, and periostolite. Okay, what are the engineering applications in our natural fiber composites? Actually, the natural fibers are increasingly gaining attention as their application is diversified into engineering fields such as automobile structural parts, building materials where lightweight is required. Similarly, the mechanical and physical characteristics of composites can be modified by adding filler phase to the matrix body during the composite preparation. Suppose if we are getting any less value in mechanical and tribological value, if we add some of the fillers or powders into the natural fiber composites, then only we can get the positive result. Okay, see that last word. The incorporation of filler or powder in composites is to improve the mechanical properties. It may be that filler may be considered as powder or fibers also. Okay, last one. Low cost and less tool wear during its machining process or among the known advantages of plant fibers, and ease of recycling makes them eco-friendly. Okay, it is the continuation of the previous one. The natural fibers are obtained from various area, particularly plants, animals, and geological process. Okay, so they can be used as a component for composite materials where the orientation of the fiber impacts the properties. The natural fibers can be used for high-tech applications such as automobile parts. So nowadays, that most of the natural fibers using for automobile applications, particularly that car door upholstery, okay, that bumper, mudguard also. Okay, so compared to composites reinforced with glass fibers, composites with natural fibers have several advantages such as lower density, better thermal insulation, and reduced skin irritation also. Okay, so nowadays most of the researchers have been exploring further use of these fibers in composite materials, as the strength of plant fibers mainly depend on cellulose. Extensive research work is carried out to develop a wide variety of natural fibers. See, here I am showing few examples of natural fibers: jute, sisal, kenaf, flax, wood bulb, bagasse, pine, cellulose, and bamboos. Here I am showing only few because of lot of natural fibers are available in and around us. Next, what are the applications? Okay, here I am showing the applications of natural fiber based on the resin matrix. Actually, in our researchers previously used and now also they are using only three different or four different categories. First one, epoxy resin, polyester resin, vinyl ester, and polypropylene also. Okay, so whenever we take any one resin to the natural fiber composites, we can get different type of applications. So normally, if we are using epoxy, we can get helmet and mirror casing. If we are going to take polyester, we can get that interior and exteriors of vehicle. Okay, similarly, we can whenever we can go for polypropylene resin, we can get paperweight ceiling panel. Okay, so here I am mentioning only three. One more is there, that is the vinyl ester. See, what are the advantages and disadvantages of natural fiber composites? So normally in the natural fiber advantages is very low specific weight. Okay, compared to glass, higher specific strength and stiffness. Similarly, renewable resources, low CO2 emissions. At the same time, production requires very less energy. It is also very friendly processing, no wear of tools and no skin irritation. Okay, similarly, production with low investment at low cost, good electrical resistance, as well as good thermal and acoustic insulating properties. Particularly, it's very important advantages is this type of composites. That means natural fiber composites is biodegradable. Okay, what are the disadvantages are there? Very low strength, especially impact strength is very low. Next, variable quality influenced by weather. So according to the environmental, that means atmospheric, it will affect the quality. Next, poor moisture resistance, which causes swelling of fibers. It is very, very important drawback of natural fibers. Next, restricted maximum processing temperature. Next, lower durability. Then poor fire resistance. That final one is very, very important. Hydrophilic or hydrophobic nature of natural fiber composites. Okay, so what is the meaning of hydrophobic and hydrophobic uh, characteristics of natural fibers? Actually, it is the higher moisture absorption characteristics of natural fibers. Due to this type of problem only, most of the researchers are avoiding to use this natural fiber and natural fiber composites areas. Okay, how to eliminate or how to avoid this natural fiber in hydrophobic nature? So hydrophobic nature can be removed some of the surface treatments. Okay, so what are the treatments available? First one, alkaline treatment, acetylation treatment, acrylation treatment, bleaching, benzolation, isocyanates. Okay, similarly, we can go for permanganate, peroxide, malated coupling agents, and permanganate area. Okay, so what is the importance of this surface treatments? Actually, see the left hand side first figure. So normally in natural fiber contains non-cellulose and wax coating, some of the impurities, at the same time hydroxyl coatings, inorganic materials are already inside in the natural fibers. So if we are going to contact anyone about treatment, automatically it will remove the unnecessary impurities from the fiber. Okay, so next, see this diagram will explain all those things. So normally that first A figure represents the fiber. It may be considered a plant or wood cell. Okay, so see in that figure, lost of fibril aggregates is there. That is considered lignin, hemicellulose, cellulose. So in that cellulose, it's not a chain movement. So whenever we are going to take any one treatment, that means surface treatment, automatically that impurity and waxy substances will be removed. At the same time, that cellulose nanofibril will be get perfect effect. So that is called fibrilication effect. See the right hand side diagram. So first is the non alkali, that means untreated fiber. That right hand side, it's alkali treatment fiber. After completion of alkali treatment, that overall waxes and impurities has been removed from the fiber. Next, fabrication process. So how to fabricate the natural fiber composites? So natural fibers can be fabricate different type of work. First one, it may be considered the thermoset composite processing and thermoplastic composite processing. So see, the thermoset composite processing can be considered as the short fiber composites and continuous fiber composites. In the short fiber composites having 4 different types. First one, injection molding, compression molding, liquid molding, and spray up. Similarly, the continuous fiber composites consider 4: layup, filament binding, liquid molding, and pultrusion. The next one, thermoplastic composite processing. This thermoplastic composite processing also consists 2 different category. First one, short fiber composites. Second one, continuous fiber composites. The short fiber composites considering 2. First one, injection molding. Second one, compression molding, as well as the continuous fiber composites considering layup, thermoforming, and compression molding. Okay, so what are the tests to be performed in the natural fiber composites? So according to the mechanical, tribological, thermal, and analysis, we can categorize different type of test. First one, mechanical testing. So in that mechanical testing, we have to make the composite as per American Society of Testing of Material Standard. Then only we can go for testing, because of in the test equipments are manufactured by some specification. So according to the ASTM standard only, we should prepare the composites. First one in mechanical testing, tensile, second flexural, third impact, fourth harness, fifth compression. Similarly, what are the characterization to be performed in our natural fiber composites? First one, scanning electron microscope, FTIR, XRD. Okay. Similarly, what are the thermal stability on thermal degradable test can be performed? First one, thermogravimetric analysis, TGA, and differentiate thermal gravimetric analysis, DTA. Okay. Similarly, we can go for DSC test also, differential scanning calorimetric also. So here, next, how to identify the water absorption capability. So in if you want to identify the water absorption capability, you can go for water absorption test. Otherwise, water moisture absorption test. Okay. Final one, DMA. What is DMA? DMA is considering as the dynamic mechanical analysis. So in this dynamic mechanical analysis, three important categories are there. First one, storage modulus, E dash, then loss modulus, E double dash, third one, damping factor. Okay. Next one, what are the applications potential of natural fiber reinforced polymer composites? So according to the survey, it can be defined as that corrosion 10%, aeronautical 10%, sports 7%, medical 2%, automotive industries 36%, construction 24%, skipping industry 11%. So as per that conclusion, this applications of natural fiber composites attained very good and better results in worldwide applications. Thank you. Thank you for giving this good opportunity.